Have you ever built a sand castle at the beach? Carefully adding wet sand layer by layer to build up a tower? Just keep that image in your mind. Because really, that simple idea is the key to understanding this pretty revolutionary technology. See, instead of starting with a big block of stone and chipping away at it to make a statue, we're going to build something from the ground up. And that's the core of additive manufacturing, or what you probably know as 3D printing. Okay, so the sandcastle analogy definitely makes sense, Viraj, but what does that actually mean when we're talking about, engineering? Let's get into what it officially is. Precisely. At its heart, additive manufacturing, or AM, is all about building a three-dimensional object directly from a digital file. There's no cutting, no drilling, no chiseling, none of that. It is purely addition, one super thin layer at a time. Oh, I get it now. So basically, with additive manufacturing, you're creating something from pretty much nothing, whereas traditional, or I guess subtractive manufacturing, is more like sculpting. You have this solid block, and you have to remove material from it to get the shape you want, right? Exactly. You have absolutely hit the nail on the head. Traditional machining methods are subtractive. They cut material away, which you can imagine creates a ton of waste. Just think of all those metal shavings you see on a factory floor. AM is the total opposite. It only uses the material it actually needs, and that means way less waste and lower energy consumption. It's a simple funda, really. Less waste, more innovation. And this brings us to a really, really important comparison. Understanding the difference between adding and subtracting is basically the key to knowing when to use each of these technologies. Okay, hold on a second. If AIM is less wasteful and uses less energy, it kind of sounds like a superhero. So does that mean it's just always the better choice? That is an excellent question, and the answer is no, not always. Subtractive methods like CNC machining are still the champions when you need really high precision and that perfectly smooth surface finish, especially when you're working with metals. But AM, well, AM has its own very different superpowers. And this is where AM becomes absolutely unbeatable for creating things with mind-blowing complexity and custom designs. Think about a drone part that has these internal channels for cooling, or a bone implant with a lattice structure that actually mimics real bone. These are shapes that are either totally impossible or just incredibly expensive to make any other way. Right, so it's all about using the right tool for the right job. But you mentioned that AM isn't just one single technology. So what are all these different styles you were talking about? Another great question. You're right, there are a lot of different types of AM machines out there, and yeah, it can get a little confusing. The key thing to remember is that we classify them based on how they add the material. They all fall into just a few major families. Some of them melt powders using lasers. Others will squeeze out melted plastic almost like toothpaste, and some even use liquid resins that get cured by light. The principle is always the same, that layer-by-layer addition, but the technique can be totally different. So, for instance, material extrusion, or FDM, is probably what most people picture when they think of 3D printing. It uses a heated nozzle to draw each layer with melted plastic filament, almost like a really precise, robotic hot glue gun. But then, on the other hand, you have a powder bed fusion process, like SLS, which uses a high-powered laser to selectively melt and fuse tiny particles of plastic or metal powder together in a big bed, one little cross-section at a time. It is pretty sci-fi when you actually see it in action. Wow, lasers fusing powder together? That sounds like it's straight out of a movie. So it's not just about the different techniques, is it? It really feels like there's a much bigger picture here. You've nailed it, Tara. And that's maybe our most crucial point. Additive manufacturing isn't just some new tool you put in the toolbox. It's a completely new way of thinking about design, a whole new mindset. It forces us to rethink how we create things, right from the very beginning. For engineers, this technology literally bridges the gap between a wild idea on a computer and a physical object you can hold in your hand. This is the mindset that lets us create perfectly customized prosthetic limbs that match a person's body exactly, or combine 20 different aerospace parts into a single, lighter, stronger component. It's a huge shift from the limitations of what we can cut to the freedom of what we can build. Wow, so we're literally building the future, idea by idea, layer by layer. It really makes you feel that the future of design is being added, not subtracted. I couldn't have said it better myself. It really represents a fundamental shift in how we think about turning an idea into a reality. It's not just manufacturing, it's creation.